This is Complex Numbers, Part 4. Today we'll be talking about properties of multiplication. So if you remember, and if I were to multiply 1 plus I and 4 plus I, it's the same thing as 4 plus I plus 4I plus or minus 1, which is then going to be 3 plus 5i, right? 4i minus 1, 3 plus 5i, okay? Today I'm going to prove to you that the magnitude of a plus bi times c plus di is the same thing as the absolute value of a plus bi times the absolute value of c plus di. So what does this mean? It means that if I have 1 plus 2i and 3 plus 4i, taking the absolute value of that is the same thing as the absolute value of 1 plus 2i times 1 of the absolute value of 3 plus 4i. So let's go ahead and evaluate that. Absolute value of 1 plus 2i is going to be square root of 5. Absolute value of that is going to be 5. So this is then 5 rad 5. Okay. Let's now evaluate this. This is going to be the square root of, let's evaluate the multiplication. It's going to be 3 plus 4i plus 6i, right? Minus 8. That's going to give us absolute value of negative 5 plus 10i, I believe. Seems correct. And then what do we get out of this? Well, this is going to be square root of negative 5 squared, 25, plus 10 squared, which is 100, right? Going to get the square root of 125. This is the square root of 25 times 5, right? Because it's 5 cubed, which is then going to be 5 squared times 5. Gets us to that. Then it's going to be 5 rad 5. Now, if you remember, I said that this rule doesn't work for the complex numbers. So you're like, why could we separate it out like that? Well, it's because these are the real numbers. We're dealing with real numbers here, not complex numbers. So, there we go. Basically, what I've said here is that absolute value of 1 plus 2i times 3 plus 4i is the same thing as the absolute value of 1 plus 2i times the absolute value of 3 plus 4i, because both of these are 5 rad 5, right? That's what I've managed to prove during these first 4 minutes. Now I'm going to generalize it. So if I'm doing a plus bi, multiplying that by c plus di, I'm doing that, multiply them together, I get a times c, ADI, BCI, minus BD, right? Because I squared is -1. So I get AC minus BD plus, combining like terms, AD plus BCI, right? Okay. Let's take absolute value of that. This is going to be equal to the square root of AC minus BD squared plus AD plus BC squared, right? This right here is in a way acting as A. This right here is acting in a way as B. So this gets us square root of A squared C squared minus 2 AC BD plus B squared D squared. Adding on to that, A squared D squared plus 2AD BC. Adding on to that, B squared C squared. Oops, messed that up. I can combine this and that, cancel it out. Then I get A squared C squared plus, write it like that, A squared C squared plus B squared D squared plus A squared D squared plus B squared C squared. Let me rewrite this instead as A squared C squared plus A squared D squared plus B squared D squared, or rather B squared C squared plus B squared D squared, okay? This then is going to be the square root of A squared times C squared plus D squared, right? Then adding B squared times C squared plus D squared, which is then going to be A squared plus B squared times C squared plus D squared. Since these are real numbers, you can split it up. Square root A squared plus B squared times square root C squared plus D squared, which is then going to be the absolute value of A plus BI, right? That's what that is. Times the absolute value of C plus DI. Putting it up here, through algebraic manipulation, I've managed to show that these things are the same thing. So I can write it up here. Absolute value of A plus BI times absolute value of C plus DI. But what is this thing? It's that thing. So, right down here, I'm going to write down as a conclusion, absolute value of A plus BI times C plus DI. Absolute value of that is the same thing as the absolute value of A plus BI times the absolute value of C plus DI. Okay. There we go. Now there's another property which I'll prove in the trigonometry next time. Trigonometry section, which is that, well, let's go ahead and see what this means. basically meaning right here is A plus BI, right? This right here is A. This right here is B. And this right here is C plus DI. That right there would be C. That right there would be D, right? And I multiplied them together. They're some distance away. Call this value right here, this length, call that, I don't know, alpha. I'm running out of this Greek letter. And let's call this length right here beta. That length, the absolute value, right? Just a variable. It's a kind of complicated variable name, I know. But if I multiply them together, probably go like over there somewhere. This right here is going to be A plus BI times C plus DI, right? That point is that. Then this length right here is that length times that length. So that length right there is alpha times beta, right? It's the absolute value of A plus BI times the absolute value of C plus DI. So alpha is absolute value of A plus BI. Beta is the absolute value of C plus DI. That's basically what I'm saying, is that distance and that distance, when you multiply the complex numbers, multiply them together, the distance from 0 is going to be the distance one is from 0 times the distance the other is from 0. Okay? Now there's another interesting property that if I have, I'll prove this in the trigonometry part. This is A plus BI. This right here, C plus DI. Say this is an angle capital A. This right here is an angle capital B. When I multiply them together, it might be around there, maybe. Kind of seems like it. Like that. This right here is them being multiplied together, right? This angle right here is A plus B. It's the angle of C plus DI plus the angle of A plus BI. Not to mention that the distance from 0 is the multiplication of these two lengths. Meaning that this length, this complex number, times this complex number is the same thing as multiplying their lengths and adding the angle of the line going to that length, okay? This is the main idea. Okay? So, problem questions. What is the absolute value of 1 plus 2i times 3 plus 4i, or rather 5 plus 7i. Change it up. What is that? Another one. What is 3 plus I times 4 plus 3i? Absolute value. And 3, I'll do it here. What is the absolute value of 4 plus 5i times 6 plus 7i? Using the method described here. Okay? That's what we're doing. Okay. In order to do this, you take the absolute value of each of them individually. This right here is that one. This right here is that one, right? Well, absolute value of 4 plus 5i is going to be the square root of, 4 squared is 16, plus 25 is going to be 41, I believe. So 16 plus 25 is indeed 41. Multiply that with, 6 squared is going to be 36, plus 49, add it through, you get 85. Okay? So now I'm going to multiply through 41 and 85. You get, sorry, I couldn't do this in my head. 3 square root of 3, 4, 8, 5. I don't think 85 is divisible by 25. No, it's not. So, this is probably simplest form, guys. 41 is prime, 85 is 5. It's going to be 5 times, it's going to be 5 times 9, 5 times 18, 5 times 2 times 3 times 3. Wait, is it? No, I'm an idiot. So this is the simplest form. There. That's the answer to number 3. Do these two using this method, taking the absolute value of 1, multiplying it by the absolute value of the other, then getting out your answer. Okay? So, yeah. Oh, this is a long video. Why have I done this? Oh yeah, a new whiteboard.